Okay. Well, welcome to the Sqitch talk. A lot more people came than I expected, so I appreciate it. Has anybody here ever used Sqitch? Oh, awesome. Yes. Okay, so everything I say wrong, you can correct. If anyone has questions afterwards, ask those people. Okay, awesome. Well, I hope it's there. No pressure on me. So, good. All right, and not yet. They will be. I kind of found out about this talk like 2 days ago. So, yeah. Does anyone do database stuff with their software? They have to deal with databases? Oh, awesome. Okay. Hopefully, this will make your lives easier. It made my life easier. That's why I wanted to share it with everybody. Also, first, the popular disclaimer. My name is Dan. I work for cPanel. We're hiring. I don't represent my company's opinions. I don't represent humanity's opinions. I don't even represent my opinions. So that is where we are. So this is purely for entertainment purposes. So if you hurt yourself, I apologize, but not my fault. Okay, so Sqitch. I keep in the title. I say it's Sane. I keep saying that. But first, why is Sqitch? Where does the name come from? Well, it's from SQL changes. Since Sqitch is actually VCS agnostic, but we use Git, I like to think that the IT in the middle comes from Git, so Sqitch, that's the name. And it's Sane. What do I mean by that? Well, what I mean is the problems that we face when we're dealing with SQL, schemas and all that in a code, the way it addresses those problems is very eloquent, very nice. Once it clicks, you actually will enjoy doing the database part of your development. So to see what I mean by Sane or why it's so great, first we have to look at the traditional migration style, which is you have a list of scripts that are numbered, 01, 02, they're idempotent, so you can just go in and run them all in order and everything's ready to go, right? And it sounds pretty good at first, but as time goes on, you find out that you've kind of locked yourself into a corner because you've tied it to your application. So if anyone needs to maintain the SQL, they have to know your kind of micro language. They can only do it on certain machines that have the stuff installed. You might have an expert in SQL, but they don't know the language, so they end up writing a little bit of code that executes SQL. It's really complicated. It also is really limiting when you get past anything more complicated than I'm adding a table, I'm adding a view, like what happens when you have to adjust a table or adjust a view or something, a year after, and you've got a million of these things deployed in various states, so it all falls apart. And then you add in, and that's only if you're the only developer. So you add in multiple developers, teams, branches, and it's crazy. So how does Sqitch address those things? It basically has these 5 kind of core fundamental principles that it's based on that addresses all of these problems and a lot more. The first one is it doesn't have opinions. So it doesn't care if you're on Windows or Linux or if your app is Ruby on Rails or Catalyst or whatever. It doesn't matter. If you have Sqitch, you can use this on anything. The second one's native scripting. So instead of a microlanguage or code or whatever, you write the change scripts in the vernacular of the SQL you're doing. So you don't have to guess. If it's an SQLite app, you're writing SQLite flavor SQL. And that way, anybody that knows that can do whatever they need. There's no limitations. The dependency resolution is a humongously awesome feature of this. So with the numbering one, you kind of get that by saying, well, if I need number 2 to run before number 4, and that kind of works. But with Sqitch, you can actually declare this thing requires this thing, and it knows that this is already in place and that this needs it. It knows what order to do things, so you don't have to guess. If you get to a certain point of your changes and it depends on something, you can assume it's there, or else Sqitch would have barfed before that. And then you don't have to rely on numbering. Kind of similar to the last one. You can name your scripts with numbers, that's fine, but you don't need the numbers because Sqitch keeps track of where this database is at, and it knows what needs done or not. So it knows what's happening right now. And really the way it really helps with iterative development. So imagine with code, right? We branch, we do some stuff, we test it. Once we're ready, we ship it back up. And then maybe somebody else, another developer has a branch, and we have to merge changes in and get that all. But think like that with your SQL. You can't really do that with the numbering scripts. It's a lot more. If you get a conflict or you need to make a small change, it's really hard to make it happen. So Sqitch makes that easier. That's its goal, is to make that very easy. So Sqitch has no opinions. I have some opinions. So sorry. First, just the project itself is an ideal model, I think, to follow. The whole thing's very well designed, thought out. It's easy to learn. It's modeled kind of after Git. So if you know Git, the stuff we're going to see is not that foreign of an idea. The documentation is awesome. It's easy to get installed. The community is really great too to work with. They're very responsive, very positive. And it's written in Perl, so yaldi. So, but what all that boils down to is basically what I had in the synopsis of this talk. It makes collaborating on revision-controlled SQL very simple. It's also encourages test-driven database development, which we can't really get into right now, but I encourage you to look at it because it's really cool. And continuous integration and delivery, people really like it because it's very simple to do, and it's very reliable. All right, so if you see David Wheeler, the original author, buy him a beer. He's a nice guy. But again, who benefits from this is anybody that has to develop, deploy, or use code that involves SQL. So really, everybody, even our end users, because it's more reliable. So, been talking a lot. Let's take a look at some of this in action here. So I'll switch to the real slides. All right, sorry, and I also have my little cPanel thing as sort of a subliminal "come work for us" message. This basically, this part of the demo is essentially going through the online tutorial for SQLite. So if you miss a slide or don't see quite what the command is, don't worry. You can always go there and go through all this yourself. But we're going to add it to our project, do a typical dev cycle, and a couple complex scenarios. And it's actually doing these commands. They're actually running, but I've scripted them out so because the talk would be 40 minutes long if I had to type everything, because I can't type. So the things that we're about to see, again, yeah, the slides are in that tutorial, and I don't have a back button, so I can't go back. Sorry. Patch is welcome on that. The goal here isn't to teach you everything about it. It's to make you aware that it's there, that it's a thing, and of these concepts, so that when you do have to work with SQL, you have another tool to try out. And I guarantee you, once you do it and you see it a few times, you're going to love it. And again, the commands we're going to look at, it's subcommand based like Git. So we're going to go through some of the main subcommands. We can't get into all of them. There's definitely not enough time. And even the ones we do, we're not going to get into every option or whatever. But I think hopefully the idea will come across. Okay, so let's add it to our project. We probably already have an existing project, but here I'm just initializing an empty Git repository to work with. And this is going to be an antisocial network. That's what we're building here. So we have our Git repository. We want to add Sqitch to it. All we need is a name. So we're going to call it Flipper. So I run Sqitch init Flipper here. We do have a URI, so I give it that, and I tell it we're doing SQLite. And you'll see it created some files and directories. The directories is where our scripts will go, our SQL scripts to actually do those things. And the conf and plan file are what help Sqitch know what to do and how to behave. So the comp file, for instance, we told it we were doing SQL, so we see that there. Typical any INI style, pretty straightforward. And like Git, you can do your user level settings via a comp file in your home directory. So for instance, let's say my SQLite is in a weird place. Oh, it's cutting off the top, isn't it? Oh, rats. Can I? Doesn't help if I lift it up. Oh well. Sorry. Well, the good thing is the commands are always repeated at the bottom after it's done, so you'll get it there. So we're telling my SQLite client's in a weird place, so that's the path we want it. Here's my name. It's not really my name. This is the name from the example. Email. And that's what the comp file looks like now. So we see it has the funny client path and all that configuration stuff. Of course, in real life, my SQLite's not my path, so I need to change that by unsetting that value. Here's the plan file. Right now, there's nothing to do. We haven't done anything, but you'll see the project we gave it, the URI we gave it, and it has the syntax version so that as that changes and your old stuff comes along, Sqitch will still be able to work. So we're good. It's in there. Let's commit it. Now we have Sqitch. So what do we do with it? Well, typical dev cycle, simple stuff, we're going to add a table. Because in an antisocial network, you've got to track your users, right? So we say Sqitch add users and a little description. And you'll see it creates this users.sql file and all those directories and adds users to the Sqitch plan file. So the SQL scripts are for SQLite. They're in a transaction. It has a little comment at the top that kind of explains what this is for and a comment telling you where to add your stuff. So we fill that in with actual SQL, creating our table. And the revert part of it, if it's a table, we want to drop it. So let's deploy that. So I say Sqitch deploy, and this thing that identifies the database. And you'll see it added registry tables to something called SqitchDB, which is how Sqitch keeps track of where that database is at. And then it deploys our changes to this Flipper test DB that we gave. And it says it did the users part okay. So it's that create table seemed to have worked. We ask SQLite, yes, there's a table called users. Now what was the DB SQLite Flipper? What is that? Does anybody know what that is? That hasn't used Sqitch? That's exactly what it is. It's called a DB URI. So like web URLs, HTTP : whatever. It's the same thing except it starts with a DB, literal DB : whatever the engine is, / everything else. So this is a simple SQLite one that's a file called foo.db in the current directory. The bottom one's a more complicated Postgres one that has a user and a host, the database name, some connection attributes. But I have a link to the documentation for this at the end, so don't worry too much about that right now. Just know it's possible to set all this and reference them by URL, basically. All right, so back to our change. If we look, Sqitch plans modified. We have a couple of DB files and untracked files in those directories, which is good so far. But we didn't do the verify part. And that's a good policy to have, is trust that everything works when there's no errors, but just go ahead and verify. So the verify file, same thing. A transaction, we can do something to verify. In this case of a table, it's good to just do a simple select to make sure, if there's no call, like the Twitter column's missing, for instance, it should fail. So now we verified, and it says, yes, okay, the user's change looks good. But it's more fun to break stuff. So let's change that verify SQL to use a table that doesn't exist. That just to simulate a failure. Somebody manually changed something on the table, or the previous deployment failed, or for whatever reason. So we're breaking it. We run Sqitch verify, and it says there like, oh no, it's broken. So now you know there's something that you need to do. So we fix that, put it back to the correct table name. Some other subcommands we're going to look at now is status, revert, and log. So status, kind of like get status, shows you where you're at. And we've deployed everything we have, so it says nothing to deploy, and has information on what was deployed, when, by who. Now if we revert the changes, it says, okay, seems like that went good. We minus users. And, excuse me, SQLite agrees. There's no table called users anymore. And status tells us, there's nothing, we haven't deployed anything. Verify tells us there's nothing to verify. And the log tells us why. So it shows here we deployed users, and then here we reverted users. So we can figure out, like, why is my table missing? Oh, that's right, I reverted that. So everything there looks good. We'll add our .db to the getignore file since we don't want to care about the local databases, tracking those. Add our changes, and we've got our first table. That's awesome. Now target is another concept, kind of like a get remote. You know, get remote is a little piece of text that references a big long URL that you don't want to have to remember or type. Well, targets are like that with those database URIs. So in this case, I'm sick of typing DB, SQLite, yada, yada, yada. So I'm just going to add a target called flipper test. And now I could reference that. So status flipper test, it works. But I don't even want to type that, so I can set a default target. And what this does is says, for the engine SQLite, I want to add this flipper test thing as my default database. So I don't even have to type that. I could just say Sqitch status, and it's like, yeah, there's nothing deployed. And that also lets me work with several databases if I want to with different names or whatever. But by default, this is the one I want to use, which makes everything more concise, which is good. But now to make it even more concise, at least process-wise, we want to verify things automatically. So if you deploy something, you almost certainly want to verify it immediately afterwards, right? So there's some config options. Deploy, verify, set that to true. So that means anytime you Sqitch deploy whatever, it will automatically also run Sqitch verify. And same with rebase, which is similar to deploy. Okay, so we set that, commit it. Now let's look at a dependency. So our users, we want to track, be able to track their flips because they're antisocial, so why wouldn't they have flips? The only difference here from the previous one is we're adding this requires in. You see there. So -- requires says, all right, this flips thing requires the user thing. And like before, we have the flips SQL. You'll see in the plan file here, so users is just users and the time. The flips has the dependency here in the square brackets. And we edit the scripts like before, which just happened magically. Run Sqitch deploy, and we see, okay, we didn't have users before it did that. It did flips, and we're good. And we ask SQLite, what tables do you have? And sure enough, it has flips and users, which is what we want. We verify it. They both work. The status tells us where we're at. Now we're on flips. But now let's revert just the last change. So the @head thing you'll probably be familiar with Git. So that just takes off the last change. SQLite agrees. We have the user table. We no longer have the flips table. And the status shows us that too. And it says, hey, you're still missing flips. We need that. Verify, same thing. It's like, I would love to verify flips, but you don't have that. So that looks good. We'll add that all and commit it. We deploy again, and it brings in just the flips because we already have users. Make sense so far? Okay. Trying not to go super fast, but there's a lot of information. And then again, Git status now says, hey, we're good. So now, the last thing we're going to add is a view, because tables pretty straightforward, right? I only have 1 minute left? Are you serious? Why caramba? Why caramba? Okay, so we'll do this really quick. Same thing, you add a thing. This has two requires, users and flips. We create the view, we drop the view, and now we're ready to ship it. So to ship it, with software we tag it in Git, right? So with this, you Sqitch tag your database as a tag, commit that, and then you tag your Git repository, and you deploy it, and now it has this tag here. So if we check it, this is what it looks like in the plan file, and we make a little temporary directory and test the whole thing out on a different database, and sure enough, it all looks good. So we'll clean up that. When you're doing this, you can change all your scripts between tags as much as you want. There's a Sqitch bundle option to help you when you're shipping it. And boy, part 3. This is a shorter one, but I'll burn through this super quick. To make bringing in other changes easier, you want to add the union merge driver for the Sqitch plan file, because we only ever append to it. So that will help you avoid conflicts, like needless conflicts when developers working. So do that, commit that, and now you can bring in master, Sqitch rebase to bring in any changes to your local database, and tag everything and release, and now you've got your second development version. The last thing that I don't have time for is to show you how to do in-place changes. So what it was the view, we needed to add a Twitter column to the view. So instead of just adding something, we're actually changing it, and that was probably the coolest part of it. So I apologize that I ran out of time, but we will cover that later. But it's Sqitch rework is what you want to use with that. You can rework the user flips view, and it does all this magic stuff for you. So sorry I ran out of time, but hey, it worked. Yay. Oh, jeez. So if you have questions, find me afterwards. Some URLs there, and thanks for listening. That's my pause ID, the text slides. The slides will be on my GitHub somewhere there. So anyway, thank you.